Okay, so don't go for the title. It's not going to be a very funny talk. I'm going to present some experimental results to tell you what could be the information processing in the brain and how could you realize it in practical systems. Before I begin, because I was listening to several speakers and discussions, I feel that I should tell very strongly that if you do quantum computing, you do not get any incredible and unique or new kind of advantages. Basically, you just speed up. All you've got to do is software programming, logic gate, and everything is same. And because of the entanglement or something, you can speed up. But if those problems, if you take, which you need to break the entanglement to go to the next step, then you get no advantages. And basically 99% problems that we face day to day are basically where you need to break the entanglement. So there are several papers you can go through, and this is the point I thought that I should clear at the very beginning. And there was another concern that was raised during discussions that you said that quantum has not been able to affect social science largely in the last 100 years because there has been a reason for that. And the reason is that when you go from classical to quantum, you discretize your space and time world, just discretize with 2 points. And if you look at the figure, I have put there are 2 points, A and B, so we have discretized it. And if we can explore the world in between, that could be a way we can help, we can give something from the quantum world to the social scientist world, which is very new, you cannot find classically normally, and that could be a way to go forward. So this is from Owen Ward in the last 10, 12 years, this field is going through, and it is saying that between two unknown times, two distinct or discrete times, or space-time points, you can find a fractal world. So you can go expanding, expanding, expanding. So that is what I'm going to do by experiment. And to tell you why we are putting our questions completely wrong is that, just look at it. There are 16 people, one of them has got a ball. And I want to find out who has got it. In classical, it's of course very late. And in quantum also you need an algorithm to find out, but the number of questions will be reduced because of entanglement, but you need query, you need programming, you need others. But if you use 16% in a circle and questionnaire is in the middle, and the person who got the answer, he listens to it and replies back, then you can get it instantly. It is independent of the number of person sitting over there. Just think about it. So it can have a quantum version, it can have a classical version, but it is completely new way of thinking how it could be. So way back in 2005, when I first started my research, so I wanted to demonstrate this practically, that using of course all my experimental results that I will present has classical and quantum part of it. All are 2 nanometers, 3 nanometers, 4 nanometers wide. So atomic coupling, orbital coupling, and quantum tunneling measurements are there. So this is the philosophy behind it, and I will go through straight away to the video because of the short time. So this is the structure that we created, and in a moment you will find classically we switch on the central one, and there was 4.1 billion ways you can do the decision making, and it's simultaneous. You cannot do it with a classical conventional quantum computing concept. And then this was in 2008 in PNAS paper, you can go through. And this is our Nature paper in 2010, where we went ahead from that fluctuating single isolated quantum system to a 1900 by 900 nanometers. Because I was very upset with the computing people who were saying they can create evolutionary circuit like the neural network. We have showed nearly 10 to the power 53 times of fluctuations, quantum fluctuating circuits you can do still. And we solved the problems, intractable problems, which you cannot solve with normal systems. And then I realized that demonstrating quantum computing at the most advanced scale of this level is not sufficient. So we simulated radioactivity, diffusion process, and others, and we showed that within 900 nanometer by 900 nanometer means a very, very small scale, but is not enough. So we went on creating a 8 nanometer small particle, 8 nanometer, it's extremely small. But we put 3 things into it. First, sensing the environment, do the processing, of course, quantum level processing, because entire system is 8 nanometers, so everything is coupled quantum mechanically in the system. We communicated with it with laser and response. So that is what the living systems do. Take the information, process it, and respond. And then we took this material, and then we tried to realize some incredible features that a brain-like systems do. So, okay, so let's go to the EEG. So we created something very complicated architecture by printing out by 3D printer the cavities of the brain. So 250 components of the brain we printed out, we put the jelly, and we tried to generate the brain-like features. Like here, this is the machine, we connected the EEG electroencephalogram, which we measure on a real human being, and we tried to regenerate the EEG patterns and something. So these are kind of funny systems that were there. I stopped it here. This was my background, what kind of work I used to do. And then I understood that I'm not going in the right direction. I need to understand what is actually the information processing in the brain. To get that structure, I moved completely. So I started a new laboratory, apart from organic synthesis, high-tech STM measurements, the biological laboratory. So next my presentation will be on biological systems, taking the materials from the brain. And there is brain building projects going on all over the world. And then some people don't have brain. It's vacant, you see nothing is there. But this person has 2 kids and very good person indeed. He's alive, 44 years of age now. There are people who doesn't have brain, but he still does many good things. See here. And this lady is from China. She didn't have the cerebellum. So those things you study in the biology textbooks will have a serious challenge if you look at these images. Okay, no cerebellum. So those who are from the biology background, you know that if there is no cerebellum, no coordination. But she was doing fine. Okay? So now I will take you a journey through the brain. So what I say is that neuron layer is not everything. You have to make a journey from the top part of the brain to the lowest scale. I will take you absolutely at the atomic scale, from the largest scale. Okay? So your whole brain and the synaptic cord system is connected by meninges. You have some slowest or level of vibrations of maybe 10 to the minus 9 hertz, 8 hertz kind of vibrations. And I will take you slowly and slowly. So the cavities we created by 3D printers and measured. So cavities if you can take out. If you go inside, so you have now gone to the hippocampus. Those social scientists would be interested that the logical part of our brain is connected to the emotional part, and everything you decide actually filters through the emotional part. You never get any logical decision in the brain. So you went. So this experiment I would like to tell you, this is the first time we challenged that neuron is not everything. There are 3 images. The left one is the neural network. Then you have the ionic image, which you read in the textbook. The rightmost one is the electromagnetic dielectric imaging of the neuron firing. And you can get easily evidence that is a millisecond clock, and the rightmost one is the megahertz clock, that is microsecond clock, is operating faster and it is taking decision when to fire. So it is not that what we read in the neuron firing, that neuron, if you understand, everything will be done. Then you go inside that neuron and find out this microtubule. And this is the quantum tunneling image, and we are pumping it with electromagnetic frequencies. And its lattice fluctuation is occurring. So it's a purely quantum phenomenon, and we are imaging it one after another by switching it. So that means what you think is happening in the neuron at the millisecond, neuron fires at 1 millisecond, okay? And this is doing it 1 microsecond. Then I will take only one ball that is there, okay? And I will go inside, and I will show the fluctuations there. And that is a single protein I took. And it is also fluctuating. We are pumping it with electromagnetic. And this is nanosecond, 2 picosecond scale. So there is a clock, inside that is a clock, inside that is a clock, inside that is a clock. This is the thing I want to propose in my talk today. That if you start from the largest structure, if you go to the smallest, right now we will show you, this is the monomer. That means a few beta alpha helixes inside a protein. and you can find it is also showing a particular kind of frequencies at the terahertz speed. That means less than picosecond. We moved up to femtosecond. So we started from the milliseconds and seconds range and to the smallest part. So whole thing is interconnected. So this is the DNA, live imaging of vibration. So you can see triplet of triplet. 3 bands are there, so 3 clocks and some clocks inside. So whole brain looks like this kind of wheel when you try to measure the frequency response. And then when this connection is there, what is the information? What should be the information? So here you can hear the neural sound. This is not noise. And this is called bits or information. And I want to break this concept. So I deconstruct each bits. Now listen to the music. Here, this is the vibration going on in a single microtubule, and the whole music is playing for one time. So when you are trying to understand me, your neuron is firing 1 second. But for that to happen, ion channels are also doing information processing. And everything is happening, so whole wheel has to rotate once to get one file in your brain. So there is clock inside a clock inside a clock. So how does the time looks like? So we studied 26,000 proteins. The whole brain is just like this kind of chain. And we can construct the whole system. So I say that information in the brain is actually this kind of clock cycle inside a cycle inside a cycle. So that is the time, not 0, 1. And if you take a projection, it looks like a 0, 1, 0, 1 prediction. So the whole thing is very different from what you apparently think. And if we use this particular concept, then there are many provocations. I'm not going into details, but there are serious implications of this in the social science I thought to discover. But the perception that you think that the robots, giant robots will come and will try to kill you, this is not ever going to happen. You need only a tiny 8 nanometers. I have that kind of robot. Little bit of modification then kill you off. Who is going to make this? So these are just nonsense, and there are many multi-billion-million-dollar projects that are running on world security. So those I just make a fun of that because of where the information is there in the nature. First, you don't know. First, and second, you think that just speeding up with quantum computing will give you everything, and these kind of things are being played. You should fear this. These are the cutest robots in Japan, just beside me, beside my house. And I often play with it. It is so cute, you can't leave it. It reacts with you, and if you go out after hugging it, and it will start crying. So it will get you done everything that it wants to do. The army could be like this. Or even ants. Look at this. They take only 2 to 3 decisions to all these things. And how do they do it? How do they do it? They manage the time cycles, the nested time cycles. So that is what I want to offer, that if you are a social scientist, you take the deconstructed part of the discreteness. If you try to go to the classical, when the collapse has already happened, and you are trying very much to do that, your efforts will always be in vain. So in summary, so in future, we are going to have bad robots, because if I don't build it, artificial brain, somebody else is going to build it. And when you don't build the unconscious, when you build unconscious robots, that will be operated by humans. And humans are much more dangerous than robots. So they will operate it in the way it does. So how do we can survive? We have to make the brain conscious. Make the robot artificial brain conscious. If it is unconscious, it is just intelligent, it's dangerous. So there will be a phase in the world when we will have this kind of situation. And if we take the nested time clocks, we can tell that the consciousness arises at the 12 triplet of triplet bands, the music that I played for the humans, and then there is a split. One machine can give 2 different solutions. So you can close your eyes, the machine can close eyes, go outside the body and evaluate the same machine and improve it. But if we just expand it, then we'll find that if we want to create G+, means you know already that if humans understand how the brain operates, then they can understand whole of social science, right? If human understands how the brain operates, then they can easily make a machine that has the intelligence level of the humans. But that is the last machine made by mankind. Because if you make G that is equal to human, you can make G+. The G+ will be made by the G++. They will do it. It will take over. But there is a but. If you follow this kind of protocol that we have discovered, the National Time Protocol, then you will find that to make the next one, you need 18 triplet bands, which is huge mass. So there is a saturation. And if you do this, data deluge is like a cancer to the human society. So data is expanding. We can show that if you put your information like the way we have said, it will shrink only a few information. So because of lack of time, I could not put the video files of sound files, how the information could be shrinked to a small few frequencies, and you can store an enormous amount of informations. And so my concluding remark on number 5 is that nested time clocks can help bridging classical and quantum. There is everything quantum, but at the same time, you can take the effects to the classical world. So basically the small time inside the faster time clocks. Everything result that I showed is a quantum systems. And the measurement in the brain materials that we carried out is also quantum. But we control them with electromagnetic, which is purely classical. So this is the way to go forward. If we continuously force entanglement and collapse and something and then try to force the social science, you'll end up doing something. We come here, many people, quantum people will come here, because of politeness, they will say, okay, fine, great, clap. And then later they will not believe. This kind of conferences will continue to happen. But there will be no way to go forward, because I will go back and then I will shut down my mouth. I will not just say the truth. So I think this could be a possible way where you can offer something new to the world, that every single human beings are also connected. The earlier speaker who said that all humans are wave functions, there is a point to it. Because when I said whole big waveform, there are small waveforms. So everything is connected. So these are my students, and thank you everybody, including every single member of Q3. You have made our staying here so pleasant, I can't thank you more than that. Thank you everybody.
Well, I'll start with some introductory remarks, perhaps. The link, I think, is Anirban showed you that spike train and said that we should be looking for the clock within the clock. But I am aware that many of you are social scientists interested in international relations, so perhaps we also need to think about moving up a scale, looking at the clock outside the clock and outside. But we're going to start at the spike nonetheless. And the other introductory comment, I'm going to come back to a couple of questions that were asked of, I think it was Jerris in the first talk, and by Michael Bierchuk. So I think you were saying, are we talking about quantum interpretation, or are we talking about the hard quantum mathematical formalism? And I'm hoping that my talk will introduce you to a way we might actually use the hard quantum mathematical formalism. And the other thing, I think there was a question there, it might have been for the same talk, are we looking at something which has got some true ontology, or are we just looking at epistemic probabilities? And if it's epistemic, in other words, just a reflection of our uncertainty. And if we're just looking at epistemic probabilities, well, can quantum mechanics only ever be an analogy to that situation? So I'm going to, at some point in my talk, show you that perhaps there is a way that even situations where probabilities are epistemic, that quantum mechanics might have a role. But my talk is entitled The One Mind, Many Brain Paradox, and Schrödinger got involved in this debate in Mind and Matter in 1958. A submind is an atrocious monstrosity, just as is a plural mind, neither having any counterpart in anybody's experience, neither being in any way imaginable. This would now probably be called this idea of the unity of consciousness. And the other more recent, but still quite a long time ago, quote from Thomas Nagel, philosopher of consciousness. I love this one. It seems inevitable that psychophysical explanation will apply first at the level of some kind of elements of experience, however you might define them. But if these elements come together in a single consciousness, they must also be components of a single point of view. So that's linking the unity of consciousness to a vast array of neural elements. And this idea of components in a single point of view, I'm always trying to put things into some sort of mathematical form. I think what he was saying, that there should be something like a something like a vector theory of consciousness, perhaps some sort of mental state vector, which could be resolved in some way into these components, these neural elements of experience, in some sort of mathematical subjective space. So this is just trying to what is it we're trying to describe here? So having said that consciousness, though unified, is not unidimensional, you might just, in terms of depicting it, nonetheless just depict one single dimension and say that, you know, there's a unity to consciousness, it's single valued in time. But also it seems to have this evolution, these dynamics which are smoothly continuous, and this idea of a stream of consciousness that came initially from William James. So there's all sorts of other characteristics of consciousness, but those are the only ones I'm going to need and work with today. So where do we go with this, and where are we going to look for these neural elements of experience? Dave Chalmers, the guy who came up with this idea of the hard problem, one of the major philosophers of consciousness, by the way, he'd fit right in here if James want to invite him next year. He suggested that really we need to basically bring in a description of consciousness into the neuroscientific model. We need some form of bridging principles, basic elements to our theory, not to be further explained, that add the minimal component to bring subjective experience in. Some would say this is a cop-out, but I think it is a necessary step. And so I'm going to suggest one to you, and which I'm also going to try and explain, because this is hard to get your head round. There's this idea of coding, and that even a single sensory neuron may contribute to the neural code for the sensory environment. But that would be accepted by most neuroscientists. It's got nothing to do with consciousness. But then the correspondence principle is perhaps that there is a neuronal element of experience and an overall sensory percept, and that these two things, both the coding and then also the mental representation, parallel each other. Okay? So we might be looking for a neural element of experience. Does this make any sense? I'll just show you a little bit of neuroscience. So you probably can't make out the pictures, but this is one of the classic papers of neuroscience. This is the Halle-Berry neuron, which you may have heard of. It was caused a sensation where I work in 10 years ago. So at the time, Halle-Berry, for those who've never watched a movie, she was probably one of the prominent actresses of the day in 2005. Now, these results were from single neuron recordings in awake, experiencing human beings who happened to have epilepsy and had these depth electrodes, but single neuron recordings. And they just, once this was to look for where their epilepsy was emanating from, but while these electrodes were in, which happened to be in the mesial and inferior temporal lobes, they sampled individual neurons and with vast arrays of visual stimuli. And this wasn't an exception, it was a rule. They managed to find specific things that specific neurons seem to respond to. And in this case, the concept of Halle-Berry. So this particular neuron, it's the top 10 or so exemplars there. Either her picture, her name, Halle-Berry, that neuron will fire. But it will not fire to any other picture of some other actress. The other really interesting one, at the time there was a movie called Catwoman that had come out, and Halle-Berry was Catwoman. So when, I think it's number 51 there, when Halle-Berry's dressed as Catwoman, then that neuron fires. But if you just write the number 94, it says Catwoman, that doesn't fire the neurons, it's not specifically. So at least in terms of representation, nothing to do with consciousness perhaps, that it's reasonable to consider there might be a neural level of explanation. But what's that got to do with coding? Is it actually doing anything? Well, you can also find neurons which are functionally specific to motion in the area of V5. These are actually monkey experiments. So you can actually sample a single neuron in the visual area of V5 which has a receptive field for part of the visual field, and also has a predilection for one particular direction and speed of motion. And then what you can do is, in the top part of the figure there, you can vary the correlation of motion, how many of these little dots are actually moving in that same direction as opposed to randomly. And then look at the bottom left, you can then come up with a sort of decision making that you might be able to do just based on this particular neuron's responsiveness as to whether it's looking at a 100 or a 50% correlated image moving up or a 50% correlated image moving down, and you can come up with a sort of receiver operating curve, which is, I think, the black squares for one monkey in A, and on the abscissa there it should have the percentage correlations. But the interesting thing is these are awake behaving monkeys. So the same monkey is trained to actually respond to whether they think this stimulus is moving up or down. And the other figures, I think it's the open circles, are the optimal receiver operating curves you could do in terms of explaining their behaviour. And the interesting thing is they're on top of each other. So in other words, in this particular case, you can explain the monkey's entire behaviour in this paradigm by the firing rates of an individual neuron. So it certainly does seem reasonable to say that single neurons contribute in a very major way to coding the sensory environment. Hopefully I've convinced you of that. But what about this correspondence principle? I'm supposed to be talking about the mind-brain problem. One thing neurologists do is, in epilepsy, put these grids of electrodes over the surface of an area of the brain that might be where an epileptic seizure is emanating from. I sort of mentioned that kind of study before, although looking at the single neurons in that case. But the other thing you can do then, once these grids are in, is you can put an electric current into just one, it could be much tinier electrode than that. And the amazing thing is, if you're in the right area of the brain, you can create a very specific phosphene. The person will say, I see a dot just there. Oh no, now there's a dot there. And you can control that depending on where you put the electric current in. It's pretty hard then not to say that what this person is experiencing has got a lot to do with the electrical properties of what's going on in the neuron at the time. And then finally, to argue for my correspondence principle, this is just lots of these examples, but for example, how do we represent and perceive colour? These are just the absorption spectra of the three different cones in the eye. So obviously, light frequency or wavelength is just a linear property. But what the eye does is it actually constructs a two-dimensional representation of colour for something which is unidimensional. It does that by the next level of neuron above the cones is actually looking at the mid versus long wavelength, or the long versus mid, if you see what I mean. They're looking at opposition of those. And so basically you end up in terms of colour representation as in a sort of two-dimensional pattern. What's interesting is if you actually come up with a colour space, that's the diagram on the right, in which basically this is the LAB system of representing colour experience, that you also have something very similar, where, for example, red is opposite green and yellow is opposite blue. And while I'm talking about this, look at the bottom right-hand corner of the starred blue area. So just keep staring at that spot. And you might say, oh, still, is it really anything to do with experience? Well, hopefully this will work. Probably not, because of the light in this room. But there's also phenomenal colour opposition, which seems to depend on exactly the same kind of opposition at a single neuron level is the feature of the representation, the coding, basically. So I think there's at least some evidence in support of my correspondence principle. But if that's the case, if there is a neural element of experience, and if we say that experience has got this smooth stream, then we should have a neural element of experience which is continuous in time and smoothly has smooth dynamics. Where would we look for that? I think I'm going to assume you know basics of the neuron doctrine, so I wasn't sure here. So such things as excitatory photosynaptic potentials, trigger zones. There's a whole lot more going on inside the neuron that I have to add since Anirban's sitting next to me. But you have individual spikes depolarize the entire neuron, and only the spike will cause neurotransmission at a far distance at the axon terminal. So this is the crux of my talk. Where are we going to look for this neural element of experience, this smooth dynamics? Here, imagine you're presenting a red dot, and then you have a spike trace which follows from it. And you imagine you do this 1,000 times, and in a similar sense to what we did with motion, that you actually had found a neuron which responds to this particular red dot. Well, unfortunately, it looks a little bit discrete and discontinuous. And in fact, the only thing that looks continuous is when you have this ensemble of traces and you take an average over that ensemble at a particular time after the presentation of the stimulus. That neuron, well, it's either depolarized or it's polarized. But yet we say at that moment of time what it's representing is best measured by that instantaneous firing rate, which is a feature of the ensemble of presentations of the same stimulus. So it seems then you have one subjective state and two potential objective states looking at just one neuron. If you then suggested perhaps, you know, all 10 to the 11 neurons in the brain are involved in consciousness, even if that's an overestimate, you would seem at the whole brain level to have one mental state and two to the very large number of potential objective brain states on which that mental state would depend. That's the one mind, many brain paradox. So what matters now experience depends on a statistical ensemble of states, only one of which actually exists. Can you see there's a problem here? Hopefully you do. But there is actually a solution in another area of physics. In statistical mechanics, if we were to describe what's going on in that box of gas, we would say, well, there's actually only, taking a very classical view here, there's only one actual microstate of that gas, all the positions and momenta of all of those particles. But there are millions of potential microstates consistent with the macroscopic properties, for example, pressure, temperature, that sort of thing. But this whole subject of statistical mechanics, you say, well, what's important? For example, what determines how much work I can do with this gas depends on the entropy, which is actually something that depends on the number of potential microstates that exist, even though we say classically only one of them actually exists. And in thermodynamics, you take this idea as well that each actual state of the universe is manifest locally as just one microstate. And so we have a vast number of potential microstates of the universe. We have the same problem, hopefully you're starting to see. Hopefully we're starting to. That in a physical system, what matters now, entropy, depends on a statistical ensemble of states, only one of which actually exists. That's the same slide I showed you before, except I've substituted entropy in physical system. But actually in physics at least, hard-edge physics, there has been progress. This is not accepted by all physicists, but the bottom line is that you can also consider these probabilities of microstates in statistical mechanics to be something akin to quantum mechanical probabilities, where you assume that there is not a vast array of potential states of the universe manifest locally, but just one, and that the statistical ensemble that you see in the system that you're looking at is really just a consequence of local reduction, which really means only looking at one small part of a system, which is actually, in fact, composite. The conclusion of that very technical and mathematical paper is that actually a probabilistic mixture of all potential microstates is the local reduction of one pure state of the universe. And that those of you who have followed where I've gone with this so far will realize a major problem for many physicists with this is that those microstates in statistical mechanics, they're thought to be just a reflection of epistemic ignorance. It's not that it's a quantum mechanical level, they would say, it's just that we don't know which microstate exists. So we're applying quantum mechanics to epistemic probabilities if you buy this paper. And so what you would then do is to describe the universe dynamics is you say, oh, well, we've got this energy, or the Hamiltonian of our system, the energy of the environment, and you've got the energy of the interaction between them, and that energy, the whole lot of that stuff at the bottom, generates this unitary smooth evolution. But I'm going to suggest to you we're sort of concluding here, that a probabilistic mixture of all potential neural states is the local reduction of one pure mental state of the brain. And just used the same thesis but used my terminology. What you would do is come up with some hypothetical two-neuron brain where you've just got A and B and interacting, and then you'd say, well, we have something which, sounds catchy, we'll call it nervous energy of neuron A and of neuron B, and an energy of the interaction between them. So, what sort of mathematical form would that take to explain something like this? Well, actually, that's been done. That's done all the time in physics. That's basically an interaction that results in energy dissipation. Okay? So there's no problem with that. So I'm going to leave you there, really. If you've all I was asked at some stage to come up with questions for the panel to confront, and I think I'm the only one who did it. So. Yeah, the only thing I'd say is what's written down there. It's in the end of my abstract. The last of the first of the questions that's written should be the last of the questions, and we can discuss them further if you like later. But I'll leave it. Thank you.
Great, thanks, Andrew.
First, I'd like to thank James, Raleen and the team for inviting me here today. It's been a fantastic meeting. So what we have here is, first of all, I'm going to briefly talk about quantum biology and then see how that relates to brains. So what has been very surprising in biology is that quantum mechanics seems to play a bigger role than we think it does. And what this slide illustrates is the border between classical and quantum mechanics. Classical stuff like steam trains on the left, Newtonian mechanics, thermodynamics, and then on the right, the weird quantum stuff. And what seems to be the case is that life lives on the edge between the classical and the quantum worlds. What I'm going to use throughout this talk is the idea of quantum mechanicals is wave-particle duality, illustrated here by a drop falling into a pool. The particle represents the drop. When it's into the pool, it generates a wave. And that wave is a kind of spread out information of that particle. It's an analog of quantum mechanics because it's wave mechanical. And what quantum mechanics does, it turns matter into waves. And essentially quantum mechanics is a combination of particle nature and wave-like nature of matter. So in order to think quantum, think wave, think field. Essentially what is happening with the wave is the particle's existence is spread out through a field of space. Okay. And what we're saying is life is rather on the edge of those two. Now, the double slit experiment illustrates quantum mechanics. Essentially, light is shone through a hole to generate a wave, and that wave is able to go through 2 points in the second barrier and then emerge, and the waves coming out interfere with each other to generate an interference pattern on the screen. That is a signature of wave mechanical behavior. What makes it quantum mechanical is when you can do that with particles. And that's what's shown. You can fire atoms through a two-slit experiment. They generate interference patterns. So atoms can be in two places at once. They can explore different routes to get to from one place to another, just like a wave can. And that's the key thing about quantum mechanics. Now, another key concept that we have to get our heads around is coherence. Quantum mechanics requires that the wave nature of matter is coherent, and that's like the coherent waves on the right, where all the peaks and troughs are in time, like people pedaling a bicycle all in step, and that generates the quantum mechanical aspects. Once you get incoherent waves, where the peaks and troughs aren't in phase, then you become the classical world. It washes out all the quantum stuff. And that's what happens when you get large numbers of particles bumping around. All their wave properties become classical. So big complex things like the storm on the left is a purely classical phenomenon. The atom on the right is a quantum mechanical phenomenon because it has its electrons in its shells are coherent waves. So what is life? Same material as the stuff on the right, but it has this fantastic dynamics that we don't see in inert material. And the problem is, this is what the inside of a cell looks like. It is a fantastically noisy system. And you wouldn't expect this to be coherent. Coherence would normally expect to be washed out extremely rapidly in such a complex, vibrating, hot, wet system. But Erwin Schrödinger thought that it wasn't. He conjectured that life depended on quantum mechanics, and particular genes were quantum mechanical entities. Was he right? This shows the letter of the genetic alphabet, a base pair, guanine on one side, cytosine on the other. This is how genetic information is encoded. This is a single letter. What those dots between the two sides are protons. And essentially genetic information is encoded by the position of those protons. You can take away the rest of the scaffold, and essentially this is proton information. This is information at the particle level. The level of fundamental particles is the information that makes the color of your eyes, the shape of your nose. It's quantum level information. And it's been going around for 3.5 billion years. And it's the kind of thing that now on IBM are able to write quantum information with atoms, but life has been doing it for a long time. Now, we're going to have to quickly zip through some examples of quantum mechanics. One is photosynthesis, where light is captured and then transported to a place called the reaction center. What has been discovered is that when that light is transported to the reaction center, and this you can't really see it very well, but it's a complex place, and that light energy could go through multiple paths, it actually travels as a wave, as a quantum mechanical wave through the reaction center. And that's responsible for the efficiency of photosynthesis. Another aspect of quantum biology is enzymes. Enzymes manipulate atoms. So they're quantum engineers working at the quantum level. One aspect of how they do that is quantum tunneling. Quantum tunneling allows particles to go through barriers. Enzymes do that for electrons and protons and allow them to pass through barriers. And that's part of how enzymes are so efficient. Birds seem to use quantum mechanics in order to navigate around the globe. Their compass is based on wave mechanical, or appears to be based on a wave mechanical property. Particles that are separated but wave mechanically connected are able to sense the Earth's magnetic field. So these are aspects of quantum mechanics in biology. The key characteristic of them is they involve small molecular systems, relatively small numbers of particles. And now we come to the bit that this talk is about: consciousness. The problem of consciousness. There are many problems of consciousness. The one I'm going to deal with is the binding problem. What is the binding problem? What do we see here? We see an impossible triangle. How is that encoded in the brain? The problem is that the different aspects of that triangle are encoded by different neurons in different parts of the brain. That's illustrated on the right here. How is it brought together, this information, to make an object that is impossible? They're joined up. Here's another example of the binding problem that I think is implicit in meaning. Here's a sentence: the pen is full of ink. What does pen mean in that sentence? It's very clear what it means until you substitute another word in the sentence. And now the sentence means something completely different. So now the pen means something completely different. Firstly, the pen meant ink, pen, writing. Secondly, by changing the context of the sentence, of that word within the sentence, it now means something completely different. So the meaning of pen is actually provided by the overall structure of the sentence and the other words in that sentence. And what that suggests is that meaning is joined up information. It can't be dissected. It's information that is joined up. And Wittgenstein pointed this out, that despite the fact that the use of word is extended in time, its meaning is grasped in a flash. We understand the meaning of a word when we hear it or say it, we grasp it in a flash. So somehow all of the different aspects of pen, whether it means the inky variety or the sheepy variety, are all joined together and are grasped instantly. How do we do that in a brain where all the information is distributed? And this was addressed back in the 1920s by the Gestalt psychologists who were influenced by quantum mechanics and claimed that the brain is some kind of field. So it's a wave mechanical entity. So the binding problem again, what we see, what the neurons see. So the neuron dissects information and it is able to analyze a particular aspect of that information, such as a color or a line or a shape. How does that get put together? We can ask a question, what does it feel like to be a neuron? Now, Andrew's already suggested this, or already discussed this in a way. What's a neuron firing pattern? It just fires at a certain rate. So what does it see? What does it feel like to be a neuron? That's what it feels like. Either a 1 or a 0. How do you turn that into conscious experience? This is what our neurons know, and yet we know, we have meaning, we know things that are far more complex than either a 0 or a 1. And so neurons just know very little. So somehow we've got to put back the information to make it our conscious experience. What we can do is put it into a field. That's what fields do. They integrate information. This is what Anirban has been talking about. One way of doing this, putting discrete information into a field, is to make it quantum mechanical. You can do this because quantum mechanics unifies matter to make a matter field. And this is what the Penrose-Hamerhoff solution to the consciousness problem, turn the matter of the brain into a quantum mechanical field based on microtubules. The problem is, back to this business of all of these particles, microtubules are extraordinarily complex structures, and the possibility that one of them can remain quantum coherent is very difficult. The possibility that trillions of them can remain quantum coherent, any physicist would say no, they can't. I don't know any physicist who believes this theory, and I know plenty of physicists. But you don't need quantum mechanics to integrate information, to join information up. Classical fields do it. There's an electromagnetic field around a magnet. And something very interesting about a field, a lot of people have laptops, they have antennae within them, and you can download a movie in this room from a tiny point in space. And that's because it's downloading information in the electromagnetic field generated by the router, and everyone around this room can download exactly the same highly complex information from a point within that field. And that's because fields, classical fields like electromagnetic fields, have exactly that same quantum mechanical property of unifying information such that every part of the field contains the same information. So you don't need quantum mechanics to join up information. Electromagnetic fields do it very well, as your computer is able to access. Is there an electromagnetic field in the brain? Of course there is. It's the brain's electromagnetic field, which is generated by neuron firing. Every time a neuron fires, it generates a pulse of electricity that contributes to the electromagnetic field in the brain, and this is what is detected by EEG and MEG. It's there. We know it exists, and it is integrating information in the brain. Every neuron that fires generates a pulse of information that fills that electromagnetic field. And what is interesting is it's recently been discovered, only in the past few years or so, that the electromagnetic field in the brain actually contributes to neural firing itself. It affects neural firing patterns. So there's a loop of information where information in the matter side of the brain, the neurons, the neural firing generates electromagnetic disturbances in the EM field of the brain, and that in turn influences neuron firing patterns. So that is important in consciousness, because what it allows you to do, so this is the CMI field theory. Digital information within neurons is pooled and integrated to form an electromagnetic field in the brain. That happens. We know that happens because we use EEG to essentially read what the brain is doing. Consciousness is the component of the brain's EM field that is transmitted to neurons. It is thereby capable of communicating its state to the outside world. Free will is our experience of the action of the brain's EM field on motor actions. And William James has an interesting quote there. If consciousness could load the dice, can exert a constant pressure in the right direction, can feel what nerve processes are leading to that goal, reinforce and strengthen these, etc., then it would be of invaluable service. So the EM fields of the brain are constantly pulling and tugging on the neurons of the brain, affecting neural firing patterns. And that could be what consciousness does. So CMI theory solves the binding problem because it binds information. All we're doing is going from Einstein's equation, the right-hand side, matter, to the left-hand side, energy. and saying that consciousness is on the left-hand side of that equation rather than the right. So there's nothing magical about this. It provides us with a deterministic free will. Consciousness is generated by the unconscious matter-based processes of the brain when they're reflected into the EM field, and free will is our experience of the EM field's action on the neural firing patterns of the brain. It provides us with a scientific dualism. Our conscious mind is an electromagnetic field that integrates information, whereas our unconscious mind, all the other stuff we do unconsciously, is discrete information processing, which goes on in the neurons exactly the same as discrete information processing goes on in computers. It provides meaning because all the information of complex stuff gets joined up in the electromagnetic field, providing gestalt meaning, and the ability to compute with complex gestalt objects, concepts in the brain, may be what the conscious mind does, and the advantage that the conscious mind was able to provide to brains that is currently lacking in computers like our laptops, because they still compute entirely digitally and discretely with matter. If we could make computers that compute with fields rather than matter, then I would predict that they will become conscious. Okay, and that's really summing up some references on the left of the theory. So you don't need quantum matter fields to provide a wave mechanical consciousness. The brain's EM field is there. It does all we need for what we need for consciousness. It's entirely physical. We know it's there. It's just going to the other side of Einstein's equation. Doesn't require any new physics to provide this interesting form of consciousness, and suggests that conscious brains have evolved the capability to perform gestalt information processing, field computing, able to compute with fields of information rather than digits of information. And that may be the key advantage of consciousness that is lacking in current AI. And that's it. Thank you.
Oh, great. Thanks, Johnjoe.
Thank you very much. That was really fascinating. I've got a question for maybe all three. Just want to invite you to speculate on what a social scientist would want to make of all of this. And the simple thing is to give you a problem in social science, or in social theory, shall we say, which is, for us, the problem of other minds is an old hat, and all the rest of it talking about Hobbes and all, as the classical formulation perhaps of it. But I want to recode this as the problem of the double contingency, and problematize that even further to the triple contingency. The double contingency is, you don't know what I'm thinking, I don't know what you're thinking. We're going to have to come to certain arrangements in order to do certain things with one another, to create an order, to create projects, or whatever else it is that we do. The triple contingency is, we do that in front of an audience. That audience could be a concrete other, it could be a public, or it could be God. And historically, it's been all three in various different kinds of funds. So I mean, at one level, this probably just adds complexities, but I wonder if you wanted to speculate where your research leads us with those kinds of problems.
That's a tricky one. I kind of think that what consciousness provides us, as I've been describing, is the ability to integrate complex information. So that complex information becomes more complex as you go from your 1, 2, 3, and that then becomes a more complex electromagnetic field, if you like, in our conscious electromagnetic field mind that I'm proposing is what it is. And so to me, what it provides is at least a scientific understanding of what we mean when we talk about thoughts. Essentially, consciousness is joined up information. And how do you join up information as complex as you've described? To me, only an electromagnetic field will do it.
I think it's my problem I've had at this conference is I feel I don't know enough about social sciences truly to understand why these questions which are troubling you are such big questions, and I guess that's what I'm, why I'm here. So rather than directly, address the specific question that you've raised, I suppose out of my specific work, what I've been suggesting is if you have a composite system made up of lots of interacting subsystems, and if you see discrete events occurring in the subsystems, can you model them mathematically as some sort of continuous interaction between all the subsystems? Now, and that's all I've really presented to you in terms of my interpretation of neuroscience. But at that sort of general level, by the way, this is what I was trying to get at with those questions. I mean, I don't know enough about social sciences and international relations, but I would have thought there might be something like that you could, adopt a quantum mathematical formalism to describe.
Okay, so for me, the target has always been for me to understand what is information, because what is information, structure of the information. So for the last 100 years, we have concretely believed it is bits 01, 01. And with my research, I want to kill it and as best as possible, because I think the information in the nature is completely different, as I presented, clock inside a clock inside a clock, triplet. And 2 days back, there was a gravitational wave got detected, and you just see that plot. My papers are published 2 years before, but the plot of frequency spectrum is exactly as we found in the neurons. So, and the neuron firing and then microtubule firing and lower. So the nested clocks, doublet or triplet, we derived even from the number system. So when we were kids, we do LCM, HCM, no? 32 is divided 2 into 16, 2 into 8. Those counting, if you plot vertically along with the number system, you will find triplet of triplet. And wherever we are measuring, we are getting it. So at least 10 to 12 laboratories across the globe. Stuart Hameroff is basically initiating this process. So they are now looking at the frequency spectrums measured from the brain, conscious experiences, and other things. And almost all the laboratories are reproducing our idea. So basically, what is information in nature can tell us how information is integrated. And then we can understand what is meant by you and me. So my dream, within next 1 year, from this April, I will start uploading rhythms of the brain. All the rhythms are nested rhythms. That means I say everything is time cycle, right? So that means if you look at an image, you can convert it into music. I removed all part of those research from my talk because of small time. But later you can contact me. I can show you how even a geometric image could be converted into a music that could be encoded into the biological systems, and then you can express. So that means what I would say is the whole universe and conscious machines are basically frequency fractal, and the conscious experience that comes out it's music. So I think that's the way to go forward for social scientists, for artists, for anything. Because I also do painting, so I have started doing painting on the things. A song could be converted into a painting. So I want to do that, and I really want that. I will play a music, and somebody would say, just like a synesthetic patient would say, "Oh, it tastes sour." So that's my goal. Because if I have understood what is consciousness, what is information in the biological system, if I have understood it, I must be able to do it. Because there is only one language in your brain, in your system.
Okay. Just got some more questions. Just to come in quickly on Andrew's point. I mean, Alex thinks that the social sciences can't really progress until we solve the problem of consciousness. I'm not sure every social scientist in the room thinks that is the case. So maybe we have more disagreement than it might appear. So,
thank you. I'd like to challenge you and push you and try to engage your minds on what is a very classical, original question that we ask in international politics and international security, and that is, what are the causes for violence and aggression in humans? And there is a big debate that has been going on, lots of nuances that overall you can sum up as like it's a nature versus nurture debate. But that's a debate that has largely occurred prior to the quantum moment. So I was wondering, with your insights into quantum and your specific areas, what do you think we can gain from a quantum understanding with regards to questions over why do humans fight? Why are we aggressive? And is there space for a peace of mind.
So, in the interest of time, I'd say nothing. You'll learn absolutely nothing. It's got nothing to do with it. And really, what I think we should be trying to do is answer these, I think, really primitive questions, which were raised in Alex's video about, the mind-body problem. Where is the place of experience in science? Now, ultimately, I tend to believe that the social sciences derive ultimately from psychology, and psychology derives from more primitive neuroscience, and neuroscience derives from more primitive physics. So in that way, it will ultimately have something to do with explaining violence in the social setting. But I don't think there's any hope of saying anything new that's sensible about violence just from these speculations at such a primitive level.
Okay, I'll have a quick speculation about this, and that is that I think a really interesting question is, why do we have emotions? If we're computers like these laptops, you can get a computer to do all the kind of sensible things that you would expect an animal to do, and we are animals. Why do we have emotions? I think it's a conflict between our conscious mind and our matter-based unconscious mind. And really what is happening with emotions is that is our unconscious mind, our biological mind, trying to take control again, trying to drive our conscious mind in certain directions. So emotions are really biology pulling us in one way or another. Emotions such as lust, hunger, or not really an emotion, but fear, love, all of that are really driving our conscious mind to be more biological, to concentrate on procreation, to be aggressive when needed. All of this is actually biology taking control of our conscious mind. So I think it's a conflict between unconscious and conscious mind. It's pure speculation.
Yeah, so I would like to say that if you look at snakes are very violent because its sensory systems are not very well developed. So the hate or attitude to crime comes so in sensory systems does not acquire much complex informations. So as I have argued in my talk, that you don't expect anything from classical or quantum. These are phenomena. So you have to expect from the information structure. And I have proposed a clock inside a clock inside a clock inside a clock. What does that mean? I mean, you came here, you got something out of our talk, but you had absolutely no idea what we are going to say, right? Can computer ever do that? I mean, every 200 milliseconds, you are deciding what to express, how to express. Every 200 milliseconds. And for that to happen, your neuron is firing 1 millisecond. And for that to happen, your proteins are fluctuating at nanoseconds and then picoseconds, and then that is going on. So what we have found in our research is that when this integrated chain of clocks, so whole human is just like a chain of frequencies or clock inside a clock inside a clock. It has a smallest time scale and the fastest time scale. So when it increases, when this chain increases, I speculate that the consciousness is much more. I have not yet measured C. elegans, but we are going to do that. But currently in our laboratory, we are trying to create 3D cortical column of humans to see how it slows down. But it's my hunch as an experimentalist is that if we can somehow increase this integrated coupled frequency chain or coupled clocks to a higher conscious level, where the sensory data that we are getting from outside to our brain is much more wide. The high five, we say, in high fidelity or high bandwidth. If we increase our bandwidth, we will feel less fear and we will be less provocative towards the thing. So it has directly relation to me with the resonance chain superiority. It is not same for everybody. It's different for different persons, it's different for different species, it's different for different kind of systems. But we can measure it. And I think that could be a way to think that information richness in the information that comes in to you actually makes you more confident that there is no threat. And if you have very less information, then you always consider anything happening as a threat, and then you go on violence.
I have like 3 days worth of questions. I'll try to keep it to a couple. The first question is there a relationship between your claim that the brain could be hacked and the claim that minds are connected, which is to say, what is the mechanism for brain hacking in your theory, and what is the mechanism for connection between minds that you mentioned? And secondly, one of the variants of panpsychist theory is that the world is just information arranged in different ways, so I wonder if that reflects your view that the world is information all the way up and all the way down. And then the other thing that emerged from the panel as a whole and from my discussions with many of you across the last couple of days is this idea that the classical is much weirder than I thought it was. Actually, the quantum is less interesting than I thought it was, and the classical is far more interesting. So Johnjoe, I wonder if you would accept my description of your work as articulating the classical weirdness, and it's the weird properties of classical mechanics and classical fields that allow us to understand consciousness. I wonder if that's a good representation for you.
Yeah, I'll agree with that. A lot of what people, like for instance Alex Wen's talk earlier in the day, what they're taking from quantum mechanics is essentially wave mechanics. And you don't need to go to the quantum world to get wave mechanics. And it can have those peculiar properties that 1 and 1 doesn't necessarily equal 2. And 2 and 3 doesn't compose into 2 plus 1 necessarily. So wave mechanics gives you a completely different kind of mathematics, but you don't need to go to quantum to get that. And I think the first question was information. Yes, I think it's becoming more and more clear that information is the fundamental substrate of the universe, and consciousness is joined up information. And to me, that's I think a key kind of insight. But how do you join it? You can join it quantum mechanically, but you don't need to. You can join it up in classical fields.
Yeah, so first of all, I completely disagree that information is everything, that philosophy you are talking about. I know the history of it. I think how the information is structured and how it is integrated is the key. So for an example, in the laboratory, we do experiment, say, a complex set of protein molecules, say microtubule, and the microtubule is far away. So I pump it with electromagnetic frequency, that's what Johnjoe said, and then we create the quantum fluctuations inside. And we could create the same state into another microtubule. But every time our experiment fails, when the length of the microtubule is different. So basically, the chain of the resonance or the chain of the frequencies is the idea. Just like you tune into the radio, right? Radio frequencies are here everywhere, but we don't hear them. We need a radio to tune into that right frequency. The point is that in conventional science, in conventional nanotechnology, we have only one resonance peaks, or their fundamental resonance peak and their harmonics. That means if you have a tuning fork, 256, 512, 2F0, 3F0, 4F0. But for microtubule or these biological materials, when you measure, they have many, many fundamental frequencies. There's a composition of large number of tuning forks, and if you take any element, any tuning fork, there are many tuning forks inside. So if you can make a similar structure, you can hack it. So this is the first test that we are going to do, is to let you think what I want with a different language. That's what I said, that we will play a frequency and we will try to create some kind of feelings inside your mind.
You will make me think purple by conveying frequency information into my brain.
Only music, nothing else. So if we have really understood, our research is not fake, then we should be able to do it. Anybody in the world who claims that he understands brain or information in nature should be able to do it. If we fail, fail. Okay, fine. But we have to make the statement very clear so that we know when we fail. Otherwise, we can never succeed. We will show up. You can find in 1940s there was literature. People will make brain in 1950. Then 1950 there were literatures. People will make brain in 1960. And you know very well, Human Brain Project and other things are going on. By 2025 they will make the brain. So this will continue for more 200, 300 years. But until we make a statement that if we fail to do this, our theory or supposition has to be rejected.
Can I add one point? The best way of hacking the brain at the moment is reading the EM fields of the brain. EEG gives the best predictor of what will happen. So yes. That's another clue that the electromagnetic fields of the brain are important. The other way of directing activity is by TMS, transcranial magnetic pulses in the brain, where they put a hat essentially of electrodes on your brain and fire magnetic fields at the brain, and they can make you do various things. So that again points to electromagnetic fields being causal in the brain.
Yeah.
So I think the key is the electromagnetic fields, both generated and inputting into the brain.
That's why I say the war will be redefined. The threat has to be redefined. Those you see in the movies, those are just nonsense. So the last couple of slides that I kept is just because of this. Because then you don't need these big tanks and other things, right? Are you going to war with these big machines, dick, coming up like this and dack, this primitive, big guns? Nonsense. Those kind of things. Any person who is intelligent, they can play it in a much safer, much protective way. You will feel entertaining. I mean, they will make you a slave, and you will feel that you are enjoying.
Yeah, they already have, actually.
Yeah. You are very happy.
I've got 3, maybe 4. All right, 5 questions now. If you can keep your questions short, then please, Jeff.
Yeah. So first I wanted to kind of piggyback on Colin and respond to Andrew, that I think part of the reason why social science is invested in what conclusions you come to has to do with an anxiety, right, of what kind of machines humans are. Because there's half of social science that thinks that the job of social science is to be able to make predictions about the measurement of initial conditions and then the kinds of outcomes you'll expect. And that politically that means things like, you know, pre-crime, right? Can you predict someone before they're trying to commit a crime, right? Chicago, LA, right? They're trying to use big data to do that. Or pre-riot, right? Can you tell when food prices change what kinds of behaviors? And that would somehow take the sort of democratic processes out of politics. But the core component of that is, are humans actually a machine that can be modeled? And so I think part of the reason why people are so interested in social science is because if we're quantum machines, then it seems like it'll be harder to model. If we're weird classical machines, it may be really hard, but not impossible to model. If we're simple classical machines, then we can model it, and we're all out of luck. And so, you know, I mean, maybe we're sort of looking to you for too much, but it's because we're trying to figure out, well, are they going to model us or not? So here's the question, though, to turn that back around for Johnjoe. I like this idea that the EM field in the brain is sort of where the action of integration is, but logically, it sounds more like steam than substance. So you can read it on, you know, on some kind of magnetic resonance scan, and you can figure out something out. But my question is, why does it cohere so well? Why, when you flash an EMP at someone, do they not sort of cease to be conscious and fall to the ground? Like, what is the strong characteristic of that magnetic field?
The first thing is, you could ask the question, what correlates with consciousness in the brain? When you look at a field, like you're looking over here and you're saying, okay, I've left my watch, and you look at somewhere and your watch is in your visual field, but you don't see it. And then suddenly you see it. So all the information is exactly the same in your brain before and after you see it, but something happens, you become conscious of that information. Neurologically, it's known very clearly what happens. All the neurons in your brain are firing incoherently first, and then when you become aware of it, they fire coherently. Now, what will that do? It will send a pulse, because now you're getting coherent electromagnetic waves. Incoherent will generate zero of a magnetic pulse, because they'll all interfere with each other. But once they become coherent, then you'll generate a magnetic field that goes into the brain's global magnetic field. And that's the best correlate of consciousness, when neurons fire synchronously. So why is that? As far as I can see, no one's come up with a good explanation, but it makes complete sense if it's a way of transmitting information into the conscious electromagnetic field of the brain. So I think it will be solvable, and we are deterministic machines, but we have to take into account that our brain is a wave mechanical entity rather than just a mechanical entity. And then it will be solvable, but not quantum, I think.
When you put up the picture of the little fluffy toys, Anirban, and you made an analogy to the military people, my immediate response was, so that's how I get a hug. Now, if you were to call that a predictable response, I'm not sure which neural mixture set up which neural state to say that you could probably work out that I would probably do something like that, come to that conclusion. Certainly those who know me might. But that shows an element of assured predictability. I take out of the first two presentations, one seeks the opportunity to control, one seeks the opportunity to model and understand. But the fact of the matter is their brothers in both success and crime. The final question, the final presenter I particularly like to answer before about finding the balance between the conscious and the mind in terms of the applicability or usability of violence. I'd now like to ask you a hypothetical question based on the ethical. You learn the way in which you can play music to change the way somebody might think. From the second presentation, we know that'll work because we've modelled it, we understand, and the classical Newtonian physics may well support it. So now you have the opportunity to de-radicalise, or not to radicalise, a young Australian so that they won't go and make a decision to perhaps fight against the country to which that they've grown up. Is it ethically right, or is it ethically wrong to use the models and techniques that you seek to create to modify that mind?
I had the opportunity to do it, and I rejected it way back in 2009 or 2010. After I rejected it, one university, using my own principles, because these principles and these experimental results I'm showing since 2009, 2010, they are available free. So it was very unfortunate for me to see that that the same principle was used, and an university got nearly 80 to 90 million US dollar funding from US military to build up that kind of system. So I hope that they would fail, because there are several things into it. Because you asked questions about hacking, no? And I told one very technological challenge that is this very big barrier needs to be crossed, and that barrier is created by nature. And what technology it uses is supreme. I mean, there are many things. We have got several patents I've not showed here. It's not that easy to make those kind of, because you have a tuning fork, you have some vibration here, it goes to the tuning fork and tuning fork vibrates. You can hack it, right? But when that tuning fork is a composition of, say, 8 tuning forks, all with different fundamental frequencies, and each of the frequencies contains many others, it is not easy to build. I know how to get to that, but I would restrict myself completely into the fundamentals, so that my result never ever produces that kind of thing. That I will make sure. And the second thing is that I believe that a time is coming when you will have drone wars and robot wars. If you want to cross that time, and there will be huge death. I mean, every time I see drone, they were taking our picture, and I get panicked because I know what it can do. You want to kill some person, you just send it and kill it without any evidence, it can come back. So we are very fast reaching to a society where criminal offenses you cannot control. It will go beyond your hand. Only way to do it is to create some robotic machines which can learn and predict threat before it occurs. So you asked one question, no? How a crime is going to get created here and crime is going to get created there. You have to learn beforehand. So one of the major challenges for many governments and multinational companies is that how to safeguard the companies and protect the data, because everything is digitized now. The big data is there. Just create a little software and you can destroy millions of dollars, and that is the biggest earning now in the world. And I'm surprised nobody in this conference raised this particular issue, because this is going to be one of the biggest threats to the mankind, and we are not discussing it. And the data is so huge that you cannot solve it with classical computer or quantum computer. Why? Because quantum computer only gives you speed up. You can entangle, but who is going to find out how the rules are being changed? We all are very different here. We are thinking completely different things. And if we change our thoughts every moment, he can come up with something new, he can come up with something new, she can come up with something new. So if it continuously changes, we don't have time to write a program to run it to the quantum computer or an linear computer. You need a completely different protocol. So that's why we are investing a lot of money and a lot of resources in my lab just to create this kind of information processing architecture where we can predict the threat and jump. I removed that slide, but I really want that mankind jumps from this drone technology to the conscious machine technology. So that if the consciousness increases in us, we will understand that all these things, these drones and these things are being drone army and other kind of things, they were never going to remain in the government's control, never going to remain in military's control. It will go out of hand to the militants and ruckus is going to happen. If we go to the conscious, this jump we can make, then humanity will be safeguarded. Otherwise, note it down, it is being recorded. You will see the kind of destruction of peace will be there in the world, just because of the existing technology. The existing technologies are already quite dangerous. It's just spreading. So consciousness is, I think, jumping is the key. And to the question, I will not make it ever.
If I could just try and actually answer the direct question, which I think was if it was possible with some form of modelling that was in some sense quantum, like this quantum decision theory that was mentioned this morning, if it was possible using that theory better to predict when a young person would decide to join ISIS, would it be ethical to use that theory? I don't see that as an ethical question. It's kind of like, is it ethical to conduct any form of progress in decision theory?
It's ethical to change their mind.
That's exactly right. That's
To change their mind?
Fundamentally addressing the values of an individual.
You mean like to somehow intervene upon consciousness in some way?
But we are being brainwashed every time, right? Every single person in the world is getting brainwashed. Yeah, the news is brainwashing you, giving you some information. I was born with no religion, and I saw this thing and that thing. I start worshipping God and something like that. That is also brainwashing me. Culture brainwashes, everybody brainwashes.
Yes, I was thinking about the cognitive augmentation, and one of the issues that we found, particularly with the audio as opposed to the visual, is an ability with angry soldiers returning, particularly with PTSD, it's a way of actually reducing that threshold of anger so that therapy can actually be delivered. And I think that links directly into your thinking. But it also looks at cognitive fitness augmentation, some of the work that Professor Nangapan of University of South Australia has been looking into. And I think that links also back to the potential for red teaming. If we understand that we can improve decision-making and taking, distinguishing between the two, then we can also potentially red team that against other headquarters or structure functions. And I think that gets a little bit at the ethics that you were looking at. But certainly there's potential for reducing the anger. The problem is we can't get any funding to actually get that through current system. So how do we manage that?
Okay, Chris, and then
The question of the meaning attached to words, so the question associated with the pen is full of sheep or the pen is full of ink. But I want to try and get at what you might have to say about the clearly social dimensions of meaning. So I'm going to give a quick example. When I lived in Italy, anyone who's ever lived in Florence will know that purple is the Florence colour. So if you go to a menswear store, you'll discover that there are probably 10 varieties of different shades of purple, sweaters, shirts, whatever else. When I was living in Florence, I bought several purple shirts, and when I returned to the Australian National University, I wore a purple shirt, and the reaction was really interesting. So, first of all, women felt obliged to comment on the purple shirt, and men looked as though their metabolic makeup was disintegrating, right? There's a sort of physical reaction to the purple shirt. Now, clearly, since the question of purple came up, clearly there's a social meaning that is attached to purple in both of those contexts. Now, that's a trivial example, but there are lots of really important ones, like the right to bear arms in the United States. That phrase has a particular meaning that, frankly, it didn't have 200 years ago in the United States. The meaning attached to those words is really different, okay? So, I don't expect the biology or the neuroscience or the physics to have an answer to this, but I want to know how you think about the social meaning of things like purple? Because clearly those things are really important for fashion and politics.
Yeah, thanks. I have it's kind of a related question. A lot of the social issues we're dealing with right now are described as complex or hyper-complex. They have dynamic complexity, they have social complexity and emergent complexity. And they're calling on us for actually to be able to integrate a lot more information, a lot of complexity that is being thrown at us. And developmental psychology looks at the development of consciousness and meaning-making and our capacity to actually make sense of a world that is bigger than, than what we can do. And I was just wondering how your different theories of consciousness address this, and what might some of the research on, for example, meditation, and how that actually affects our brain activity and our capacity to, for consciousness, how does that affect it all?
So the first question was on ultrasonic. First time when 2009 we disclosed our result, then couple of people thought it's very fun, so they took ultrasound, this 8 megahertz vibrator, and you put in your brain. You will, if it is 10 to 12 seconds, you will feel very good. But if it is more than 30 seconds, you will lose consciousness. For 30 minutes, you will be just like zombie. Check it out. So there is a research going on transcranial ultrasound to help many patients, because I get regular email from many people across the globe. My son or my daughter is having seizure, epileptic seizure. Could you do something? And so this research is going on, and I am assisting many groups in US and in China and other places who are developing this collective nested time cycle based frequency instrument, which will pump you and will bring back your mood and others. So we are building it. I'm just advisor. So,
but of course, it's actually some people, the snake oil scientists, are beginning to sell it on the market.
Yeah, those things I have checked. Those things are fake. You cannot pump one frequency to there is no magical frequency. These kind of research papers are abundant in the net, and all these are fake. None of our experiment shows none of a single material in the brain has one fundamental frequency. So we need much more complex systems. That's why even those people whom I am working, they want to make one frequency. So I disconnected with themselves. So a new product is going to come out from China. They have only one frequency. Okay, so this is first question. The second question was color and meaning of consciousness. So every color is associated with particular kind of feelings, and there is a universal language for the humans. You know that Noam Chomsky's theory. So we have been trying to correlate, find out, because red means very different for everybody. You know why? Because the red color will give completely different kind of feelings, completely different kind of understanding, completely different kind of, even just look at red is very different for everybody. Because of your past, how you grew, how red was associated with many different things. So the color has direct relations with the consciousness of a person, but the color map of every single human being is very different. So we can make a color map of consciousness. It's a beautiful map to look at, and in Tibet they used to do this for a long period of time. So I can discuss with you later on to tell you how these beautiful maps and colors are related to consciousness. Third is meditation. There are several laboratories across the globe who have tested, especially in Harvard. When I was in MIT, I used to regularly go to this Harvard laboratory and watch their experiment. They have shown that if you do meditation, there are fundamental changes even in the blood vessels and others. So you can check it out. And to me, I think that the nested clocks, more it slows down, makes you better conscious. So meditation, I do meditate every day, whenever I get time. So I have seen that meditation helps in slowing down, and always I have seen that slowing down or getting control over the slower rhythms makes you more peaceful, more understanding. So there are many experimental results on these fMRI results and other things results, and it has been directly related to consciousness. So there are many proofs, and it is coming up. So we can discuss about it later.
I was just going to very briefly address this question of meaning. not that I have any expertise, but for example, if I'm just going to quote the work of Peter Bruiser, who's a psychologist at Queensland University, who's in that quantum cognition field. So if I said the words Apple chip, then the association that probably 80% of you have got is something to do with Macintosh computers, but the other 20% are thinking of chopping up an apple and deep frying it. And there's all of these different associations, and this is one of these phenomena that had not been well explained classically as to why certain people will fall one way or the other. And he has come up with a quantum probabilistic explanation of that, and I think that's good science. It's explaining behaviour we couldn't otherwise explain. And I would say, yeah, there's all sorts of potential for that kind of thing to be applied to the social sciences, but I also remain agnostic as to whether it's got anything to do with consciousness and quantum consciousness, or whether it's just we're using another nice model in order to predict behaviour.
Yeah, on the same question, the purple question, if you like. Purple to me, the singer Prince, and Purple Haze, and all that kind of stuff. So it means there's a lot of stuff in the simplest words. And I think this is how our conscious mind is able to operate. It's able to compute with big stuff that are still kind of unified within our mind. And I think the key thing is that computers are going to be rubbish at doing that, because they always digitize the information and try to process it separately. We process all of that information as a single unit, and this is what meaning is, I think. Meaning is all of the stuff associated with a word like purple being encapsulated into a single physical entity. That only happens in the brain's EM field, as far as I can see. Meditation, Karen's question, what has been shown is it makes the brain neurons fire more coherently. So what that would do, if my idea is right, is it generates less information in the brain. Essentially, as you fire more coherently, your thoughts are becoming simpler and simpler. So that's what I think meditation may do, simplifying your thoughts.
Okay, great. Well, I'm sure you're all hungry for something to eat, so what I'd like to do is thank the panelists for 3 great papers and move to the next section.